I'd like you to consider a question that's been posed by humans since time immemorial. How did life on Earth begin? My research approaches this question by focusing on the massive asteroids called planetesimals that delivered the building blocks of life to Earth. I found that these planetesimals formed earlier and are more sensitive to chemistry than previously thought. I first became interested in this research when I was an undergraduate student at Hunter College. I interned at the American Museum of Natural History and was able to work with real meteorite samples from their own collections, as well as NASA's Johnson Space Center. Because we've found organic molecules in meteorite samples, we know that planetesimals brought organic molecules and water to Earth. We've also detected organic signatures on the surfaces of asteroids in space. By combining computer modeling with microscopic meteorite sample analysis, I was able to reconstruct massive objects that were destroyed and no longer exist. Reconstructing a planetesimal is much like baking a cake. There must be strict attention to baking time, temperature, and ingredients. Here the temperature should be just high enough to melt ice, but low enough to preserve sensitive organic molecules that are the precursors to life. The ingredients are akin to the composition of the rock, which should be similar to meteorites that have retained the chemical fingerprint of the early solar system before planets formed. This research has led to two important conclusions that improve our understanding of the early solar system's history and the delivery mechanisms for the precursors to life on Earth. First, a planetesimal that is water-rich and around 44 kilometers in diameter would have formed around 2 million years before the first solids in the solar system. Some estimates put this formation age as far as 5 million years after the first solids in the solar system. So our estimate is earlier. Two, the temperature inside a planetesimal like this would be very sensitive to composition of the rock. In some models, there's only one ingredient that is considered. My model considers adjustments to both size, formation age, and associated adjustments to the composition of the rock. Based on these findings, the planetesimal that jump-started life on Earth was slightly larger than New York City and nearly as old as the solar system itself.